So our story continues. Sorry, I always start a few seconds late because this button that says recording doesn't go on and then it's already recording. Okay, the story is getting now into modern times where we begin to talk about human impacts, especially on weather extremes. And then in the other books we will use, and in the last chapter of this book, we will touch on the impacts on human health. This story of the weather extremes in modern times is similar to what we have been looking at in terms of food production, impact of weather, conflicts, people movements, infectious diseases, and other disease outcomes, except that now everything is happening in the background of human impacts on climate of the planet. So here is the latest story about global warming. These are anomalies with respect to a base period of 1880 to 1900. You can pick any base period. Things shift a little, but the main story still remains that we are warming rapidly, and unlike CO2, which increases monotonically, the warming isn't always monotonic because heat goes into the ocean. Ocean takes up 93% of the excess heat trapped by additional greenhouse gases produced by humans. Energy goes into evaporating the oceans, melting the glaciers, and so on and so forth. Okay. Nonetheless, all those evidences appear as reduced glaciers, increased sea level, and so on. So energy remains in the system. So the period we are going to look at, you can see that bouts of warming and cooling were going on, and then the monotonic warming with year-to-year differences started to take off, and now we have the warmest years in instrumental record happening in the last few years, last decade or so. So in fact, if you look at decade-to-decade warming, as we saw before in another podcast, each decade is warmer than the previous one. So 2020 tied the record for the second warmest year. I think 2016 turns out to be the warmest year on record. So overall, no good news. So to go back to our time scales, in the brief history of climate change, we already knew in 1861, Irish physicist John Tyndall, who has a center named after him now in East Anglia, already pointed out that this aqueous vapor is a blanket more necessary to the vegetable life of England than clothing is to man, he concludes. More than a century later, he's honored by having a prominent UK climate research organization, the Tyndall Center. Okay, so the impacts of greenhouse gases was being known, energy balance was being understood, and especially Svante Arrhenius, Swedish chemist, in 1896, concluded that the industrial age coal burning will enhance natural greenhouse effect. He suggests that this might be beneficial for future generations. His conclusions on the likely site of the man-made greenhouse are in the same ballpark, size, sorry, not site, a few degrees Celsius for a doubling of CO2. This is the estimate we have till now. And then a famous paper came by Guy Callender in 1937, which did much more detailed calculations and so on. Coming to health, we can use Tambora Eruption as a indicator of how global perturbations can happen and percolate through the socioeconomics and even culture and art and so on. The Tambora Eruption from 1816, Lord Byron wrote about the years without a summer. I had a dream which was not all a dream. The bright sun was extinguished and the stars did wander darkling in the eternal space, rayless and pathless, and the icy earth swung blind and blackening in the moonless air. So the impacts of Tambora and since then many other volcanoes have become well established in terms of cooling of the global climate for a few years following the eruption, depending on how big the volcanic emissions are, and they affect droughts across the globe, crops, health, and sunsets. For example, Edvard Munch's Scream came out, I think, in the 1896 eruption of Krakatau. Okay, so there is the Mount Tambora around in Indonesia. So you can see Java and Lombok and so on are here. So you blow it in, Sumbawa and Bima. There is the Timor Sea, Indian Ocean, and so on. And it put out some, I think, 15 square kilometers of, sorry, have I not put it in the display mode? No, I have not. So in case you didn't read here now, sorry about that. The quote by John Tyndall and Svante Arrhenius, much more visible now. These mistakes happen. Here is the quote by Lord Byron, was a poet. And here is the map again of Tambora. Here is the bigger map zooming in here. And this is model simulations of how the impact of Tambora was manifest in temperatures over Europe. So here you are looking at 500 hectopascal geopotential height anomaly, which, if you are not a atmospheric circulation person, may not be immediately obvious what it is, but it is an indication of the weather systems in mid-latitudes, and you can see that it is lower than normal here. In June, July there is a different pattern, and in August. But the main thing is that these patterns in the 500 hectopascal geopotential anomaly are associated with weather patterns on the surface. So you can see the anomalies with respect to some base period, and these are the changes in precipitation. So warmer temperatures tend to be associated with positive changes in precipitation, whereas colder temperatures come with negative changes or reduced precipitation. And you can see that over several years radiation was reduced, so that's why atmosphere mostly cools, the climate cools. This is why spraying the stratosphere with aerosols is being considered as one of the potential geoengineering solutions for global warming as well. But you can imagine that from Indonesia all the way into Europe as well as US, the impacts of the aerosol emissions from the volcano were seriously detrimental. This is the length of yearly growing season in southern Maine, which is the northeastern US. In 1816, the year without a summer, the growing season was half the normal duration. Okay, so you can see here the durations, growing season over many years, and here is 1816. You see the massive dip and then the recovery. So the impacts on crop production, nutrition, food security, malnutrition, etc. would have been fairly serious, other than just direct respiratory effects and so on. Let's put this period also in terms of the cholera epidemics, which was one of the major things of the modern period. It still continues. So 1500 AD, 1563, first report of cholera recorded. At that time, there was this theory, which is now discarded, called miasma theory, which implied that there was some kind of a filthy miasmic air that created all these diseases. 1660, first microscope made by Anton von Leeuwenhoek. Okay, and in 1800s, we have first cholera pandemic spreading from India to Russia during 1817 to 1823. Samuel Hahnemann identified the stages of cholera and predicted remedies. Second pandemic swept across Europe. Third pandemic across the world in 1840s to 1850s. John Snow waterborne theory transmission. Filipino Pacini linked to Vibrio cholerae. Filipino Pacini linked Vibrio cholerae to cholera. an environmental bacterium that grows on the mucus of certain phytoplankton in the water, and we have similar mucus in our stomachs. If we ingest contaminated water with high enough concentration of Vibrio cholerae, they begin to explode in our stomach, and as again human body thinks it's a foreign species that needs to be gotten rid of, so you begin to have diarrhea to get rid of it. And because of unhygienic practices and lack of hygiene, contaminated waters being used, etc., it begins to spread. Okay, so simple methods like filtering the water could often solve these things. 1863 to 1875, fourth pandemic swept across the world. Fifth pandemic swept across the world. Here's Robert Koch, who isolated Vibrio cholerae. Vibriophages discovered. Wilhelm Kohl developed heat inactivated cholera vaccine already in the late 1800s, but you can begin to see growth of population, urban dwellings, wells being used for water, practices of cooking, eating, sharing, etc. also created, and toilets created issues. Sixth pandemic, emergence of L-Tor strain of cholera. Hafkin developed heat-killed cholera vaccine. Bereska developed Billy vaccine. I'm not going to say what those are, but you can see that all along the way medicine has been after curing cholera, but cholera is still very much active, especially in the tropical countries. First use of oral rehydrating therapy, which is now still very popular. Emergence of fluoroquinoline resistant strain in India. So you can already see that species Vibrio cholerae was evolving to deal with human actions. They discovered cholera toxin, purified cholera taxin, emergence of multiple antibiotic resistance Vibrio cholerae. Not a good news. Emergence of Vibrio cholerae reported in India, Bangladesh in 1992. So we are really up to the modern times. Crystal structure of cholera toxin elucidated in 1994. So this is the story now going from 2000 AD into 2015. So fine-tuning the knowledge of Vibrio cholerae strains on the basis of whole genome sequence comparison. So now genetic methods are brought in, and various outbreaks like the one that happened in Haiti here in 2010, which killed lots of people, was blamed on certain populations who were serving in the UN Peace Corps, and then genetic methods were used to find proper attribution of the origin of the Haitian variant. Okay, so now you have vaccines and also genetics being applied to these things. This will happen a lot with COVID as well, in terms of the origin of the coronavirus, which is already being investigated because of all the controversies of whether it really came from bats to humans or whether it was something that escaped out of a lab. Okay, so we'll continue the story in the next podcast, going into other climatic perturbations and health outcomes.